Okay, so when we last left off, we were exploring how to use C++ and sockets as an inter-process communication mechanism. And what we did is we wrote a chat program so that we could send messages back and forth. So I think what I'd like to do is I'd like to get us ready for the next piece of work I created a directory called sockstream, and I'm going to copy the contents of sock chat to sockstream. All right, now let's take a look at server.cpp so we can kind of set the groundwork here. All right, what I'm interested in is how data gets transferred from the client to the server, and in particular, the data itself. So take a look at this line of code right here, cin.getLine buffer length. So what this is doing is it's extracting a group of characters from the keyboard and stuffing it into buffer. And then we squirt that buffer from the server to the client. But that works really great for an array of characters. An array of characters, which is what this buffer is, this array of characters is essentially a C string. So as long as we make sure that it is a C string that ends with a \0, the system will be smart enough to squirt the string across the entire buffer worth of data, 1024 or 1K worth of data, from the client to the server, from the server to the client. And some of the data in that buffer is garbage that we don't care about. The data that we care about is the characters up to the first \0. When we do the cn get line, the cn get line will actually insert the \0 at the end of the string that the user types in the keyboard, and then we'll make sure that when we send that to the client in this example, that the client sees that \0 and ignores all characters for the rest of the buffer. All right, that's how C strings work anyway, so that's lovely. But what if we wanted to send other kinds of data? So for example, what if I wanted to send an int? Or I wanted to send a double? Or I wanted to send a student? All right, how would those things get from here in the server over to the client? Or actually, how about this? Let's say the student's name is Bill, and let's create a string as well. All right, so my goal here is to basically send other kinds of data, an integer, a double, a string, and a student named Bill. So I think if we're going to send the student named Bill, we're going to have to populate it with some data. So Bill dot, I don't remember student, it's been a little while, so why don't we do this? I'm just going to quickly go back to the shell, and I'm going to copy student class, and I want to copy student dot star here. All right, and let's just cat main dot. We're going to look at the code that created something using the student class as well, just so we can see. All right, so we'll create a student Ben. We'll just copy all this code here. All right, so all right, so we'll just take that and paste it right here. And now we have a student Ben. So we would like to be able to send Ben as well. That would be nice. Okay. So that's our charge. Let's send these different types, this different type of data to the client from the server. All right. So we're going to rework the code for socket chat so that we'll make it really simple. We're just going to have the server send data to the client. All right. So, and the client's going to expect the data in a certain order. All right. So how do we do this? Well, obviously we're we're in a situation now where we're not just going to be sending this character buffer. We're going to be sending other kinds of information. And so what we can do is we can take advantage of the fact that it's possible to get the location in memory of each one of these pieces of data and then send that information off to the server or from the client to the server. All right. So let's take a look of about how we would send an integer first. Hello, integer. It'd be nice to send you. Okay, so we're gonna say this server. Maybe I don't even. Okay, we'll just say server sending data. Okay. Okay. So the information that we're going to send is first we're going to send that integer. All right. So to send the integer, we're going to say send CS, that's the socket. Now the next line is the address of the memory location where the data we're trying to send starts. I'm going to do my settings so you don't have to watch, let's see, notifications, I think. Notifications. Okay, so just set it so you guys don't have to watch these messages from my amazing wife. Okay. All right. And so we're going to go back to here. All right, so we're going to send to the client socket some data. And the data we want to send first, the first piece of information we want to send is this integer that has the value of 42 in it. So we can't say an I because I is the value of the integer. We're not sending the value of the integer. That's not the way this works. Send expects to see the address of some memory location. All right. Now we could send the address of, we could pass in the address of I. That would work. And then we have to give it a length. Now the length that we're going to give it is the number of bytes that we are expecting to send. And what it will do is starting at this memory location, starting at the address of I, it will send as many bytes starting at the address of I as we specify. So an integer is 4 bytes. So if we send 4, we just sent the integer. Now, I could hard code it to 4, but it would be better to just say size of int. And now what we've done is we've definitely done this right. We've sent in, we've passed in the address of I, the starting memory location of the integer I, and we said for the 4 bytes from that starting memory location, size of int, send this data. Okay. Now on the client side, we're going to have to be smart and know first we're sending the integer and we'll receive that, but we'll do that in a second. And we can do the same thing with the double. And this time we're going to send size of double. And life is good. Now, the next one is a little bit of a problem. If we send the address of S, S is an object. The string object is that memory associated with that string object, that's opaque, which means I don't actually know where the data that makes up hello from server is located. And I don't really know all of the crazy stuff that's associated with allocating and managing strings. What I need is a location of a contiguous array of data, which which makes up the this the characters hello from server. This string s is a class, or the string s is an object. So objects are more opaque, so you have to be really careful when you're sending them. You can't just send them. I can't just say send cs ampersand s size of string. And if you think about that, it makes sense because size of string is always going to be fixed. There is a fixed number of bytes associated with the string. String has members, and some of those members may be simple types like integers, but some of them could be complex types with references to things on the heap and stuff like that. So I can't send raw data. In fact, I think to make this point clearer, what I could do is just draw a little picture here to help you understand what I'm talking about. So I'm just gonna do a little screen mirroring here. Okay. So this isn't exactly how a string is laid out, but it gives you some idea of the issue. So here's S, all right? And S refers to a chunk of memory. And also I'm gonna draw I. Draw I here as well. Okay. So when we did the send for I, we passed in the address of I, which is this memory location right here. This is ampersand I. And then we said for 4 bytes, or size of int, send those 4 bytes over to the client. For S though, S is a little bit more complicated. S is going to consist of a bunch of members, all right? And those members are going to have types. So maybe like one of the members is called length, which is an int. So we have a member called length, which is an int, and maybe it consists of, well, I don't know. I don't like the way I did that. So let's go back here. So maybe we have, let's move this so it's a little easier to work with. Move it down here. So maybe there's a length, and length is 4 bytes. 1, 2, 3, 4. All right. Now, if we just created a simple, had a really simple S, maybe there's a C string pointer, all right, which is also 4 bytes. 1, 2, 3, 4. And this C string pointer refers to a chunk of heap space that contains the actual string hello from, what did we call it here? Hello from server. Okay. So this is what a string, the S object looks like. So we've got a length, which is 4 bytes, and we've got a C string pointer, which is also 4 bytes. That's the address of the chunk of memory on the heap that contains hello from server. All right, this is what makes working with a string object different from a simple type. All right, so if you were to say, what is the size of a string object, the answer that would come back is the size is always the size of string is always 8. And that's because a string object consists of 2 components. One is the length of the string, that's a 4-byte integer, and the second is a reference to a C string on the heap, and that reference is also 4 bytes. So the length of a size of any string is 8 bytes. But that's not really what you're thinking of when you ask for the size of string. What you want to know is, what is the size of this, right? Well, that's an arbitrary chunk of memory on the heap. So that's a different value. And so when we're sending information from the server to the client, what we want to do is we want to send this data. We don't really need to send this data. That's not important. We want to send this data. This act of taking something that's a complex type and converting it into something that's simpler is called serialization. Any complex object, like a string, can be converted into a series of bytes if you get down to what is the important piece of information that you want to transmit across processes. Serialization also works for files. Like if I were to say, hey, let's save this string, how would you save the string to a file? Or let's say we wanted to save a student. How would you save a student to the file? You have to come up with an order to write out the data that's associated with the object. And ultimately that order ends up taking the object, which could be a very complex, rich thing, and kind of squashing it down and flattening it so that it ends up conceptually as sort of an array of bytes, byte data. Okay, so I hope what I've done so far is I've convinced you that when we're trying to transmit a string, we're really not trying to transmit this data. That's kind of the metadata associated with the string. We want to get to the meat, the heart of the string, and that's this heap information. So we have to do a little bit of extra work, all right? And it means that the size of the data that we're transmitting is really the size of the meat of the data and not the metadata that's associated with managing a string object, all right? Now, the send command is really stupid, and so is the receive command. It wouldn't know how to handle this string information anyway, the string object anyway. What it would do is it would say, okay, well, we'll transmit the length, and we'll transmit the C string pointer, but that's it. It wouldn't know to jump over to the heap and transmit this hello from server information. It wouldn't know to do that. It would just say, okay, you said the size of the string is 8. I'm going to transmit the 8 bytes that start at the address of S. That's going to be the length and the C string pointer. Now imagine this. If I transmit the C string pointer, what does that even mean when it arrives at the client? The C string pointer is the address of a memory location inside the server process, all right? So if you're transmitting the address of a memory location inside the server process and that address arrives at the client, what is the client going to do with that? It can't access memory inside the server process. Imagine the server process is running on a separate machine. It just doesn't make any sense. So transmitting references across an IPC mechanism like sockets is just not something that you want to do. So we really want to just focus on what is the important data that's contained in the object we want to transmit, and focus on transmitting that important data and don't transmit anything else. All right, cool. So I hope I've made my point here. So let's go back and take a look at this this transmission, okay? This is not going to work. I just explained why trying to send the object S along with the size of S's type is not going to work. What we really want to do is we want to transmit the contents of the actual string. All right, so how do we do that? Well, if we're going to transmit a string, what we can do is we can access the contents of the string, the bytes that make up hello from server. And the way you do that is with s.c_str. So first for C++ strings, we can convert that C++ string effectively into a C string with the method C underscore str. And what we're going to do is we're going to copy that information from into buffer. Remember, we have that our buddy buffer that we already set aside, and we're going to do that for a length of str length c s.c stir plus 1. So I'll show you what that looks like in a picture. All right. So let's go back here. Our goal is we've got this big buffer. That consists of a series of bytes. And the size of this, we go from 0 to 1023. That's the buffer that we have. Now, how do I know that? Well, right up here with our original socket chat program, we had a buffer length of 1024. We have a char buffer of size buffer length. So that gives us our buffer. And so what we're going to do is we're going to take the contents of this heap stored data, which is buried inside the C++ string, and we're going to copy it. So when we say s.c underscore str, it gives us a C string-like reference to the data that's stored in our string s. So it's effectively a C string. We're going to copy the contents of that C string into the buffer. So what that will do when we use memcopy is it will copy the contents of s.c underscore str over to here. Okay. So we're going to have H, E, L, L, O, etc. And we're copying one extra byte beyond the length of the string. So hello from server, that's going to have a length of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So 17 bytes or 17 characters are going to get copied into the buffer. But we're actually going to copy one more, the 18th character, and that's a \0 that ends the C string. All right, and then there's some more stuff in the buffer all the way up to that final byte. Okay, so once we've done that copy, then what we can do is we can then transmit the buffer over to the client. Now, we have a choice here about the size, the number of bytes we do in the transmission. We could transmit only sterling plus the size of the string, basically the size of the actual string, C string, the bytes that make up hello from server or whatever, 18. We could transmit 18 bytes worth of data when we do the send of the buffer that now contains a copy of the C++ string. We could do that. When we do that, though, we have a challenge, which is on the receiving end, we don't actually know how many bytes we're supposed to be receiving. So we have a choice in that situation. Firstly, we could send a fixed size always when we're sending these strings. So that's what I'm doing here to keep things simple. I'm just saying, hey, look, we're stuffing that C++ string in this buffer. We're going to send the entire buffer, every single byte, even if there are bytes that aren't used, we're just going to send them just so that on the client side, the client doesn't have to know in advance how many bytes it's receiving. It's always receiving buffer length bytes. All right, so that's one choice. Second choice is we could be smart. We could just say, hey, you know what we're going to do? We're going to send the string, but we're also going to send the length of the string before we send the string. So we could send the number 18, the integer value 18 first, just before we send the string. So if we send the integer value 18, then on the client side, I'll receive the 18, and the client will then say, aha, the next thing that's going to come is the string, and I should expect that the string has 18 characters or bytes in it. All right? So a little bit complicated here, sending a string. Who knew that sending an object would be so complicated? But really, you have to think about this. We really have to get rid of all the extra cool stuff in an object and just send the raw data. And if the raw data can be of varying sizes, we have to figure out some way of managing those varying sizes. One way is just to have a fixed buffer that always has a big size and just always send that big size buffer with the big size buffer length and throw away the data that's not really meaningful data. Or we could pre-send the number of bytes associated with the data that we're sending, the actual data in the object that we want to send, and then on the client side, expect to receive that many bytes. So I'm taking the simpler route here. Okay, cool. So that's going to send the string. And then we've got the student that we have to send. So the student has a whole bunch of different parts to it. We've got Ben has a first name, a last name, a street, a city, state, zip. And we can't do this. This is not going to work. Because we're going to have the same problem as the string. The student structure consists of there's actually a bunch of regular C++ strings in there, and we know that we can't, that those strings are objects themselves, and so those are things that we're going to have to serialize in order to send them to the client. All right, and so I actually think that what we should do is this. Rather than writing, we could write all of the code to break down Ben first, last, street, city, state, zip, and stuff like that. We could write all the code to do that right here in the main program, but it might be much cooler and more useful to do this, to say Ben dot send CS. So we're adding a method, a send method, to the student object or student class, and it'll be smart enough to serialize itself and send itself across the socket. But I think using my general strategy of like, let's get little bits to work first and then and feel good about it, let's save that for last. All right. Okay. So we're not going to do this. Let's see, we're not going to do that get line or send because we're not sending a string. We're going to wait for the client message, and we're going to assume that the client message sends us, the client's just going to send us and everything was okay. And then maybe we'll end the program. So I don't even think I'm going to have a loop here. Just get rid of this do while. Clean up the code a little bit, and I think we're good on the server side. All right, so let's save this, and we'll compile it and see how things look on the server side. All right, looks like we've got a little bit of a problem here, and the problem is, what's our first error? Oh, it looks like I might need using namespace. So let's go look at using namespace std. Oh, I don't have the strings. I don't have string declared here. So pound include. I'll put it right here. Okay, I think it's string.h. I can't remember. Yeah. Uh, that looks good. All right, but now we need the socket send and receive. So man, our receive. We need another include here, so we've got to get these two. Oh no, I think we're good. Let's see. Okay, so our next error is request from member C star and S, which is a non-class type int. Oh, okay. So let's look at the code again. I have a feeling that I have to make this mem copy a void star. Hmm. Okay, let's go down and let's fix something so I can feel good about this. I think I need a 0 here, so I'll get rid of that error. All right, so now it's just mad about CStir. So let's Google C++, C++, string C underscore str. Make sure I've got that done correctly. So C underscore str returns a string. And that's good. And I wonder why it doesn't like it. It does not like it. So there's an example here that's showing you there's a thing here about CStir, which is that it's declared as a constant, which means you have to promise not to try to alter it. So when you pass it in other methods, those methods also have to promise not to alter the string. So let's do a mem cpy and see what that expects. Well, that looks pretty good. Constant void. Okay, so maybe I just need to change that to make it a constant void. Hmm. 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 All right, let's just do a little bit more tweaking here. Maybe that's not the right. Maybe it's just include string and not string.h. Aha. Okay, I'm making some progress now. Okay. Yeah, I definitely need string and string.h. Okay. Let's see if we get any closer here. All right, too few arguments in my send. All right, let's look at server.cpp and fix all these sends. They need to have zeros at the end of them. So 0 here and 0 here. Hopefully I'll get rid of most of these errors. Okay, we got to fix student. Oops. All right, and I can see that I'm still got an issue with that C string. I'll figure that out. Confident. Okay. Oh, okay. All right. Got a little error here because I've got S redeclared, so that's probably my biggest problem. We'll call S str, and we're going to say str here and str here. And I think we're good other than that. There we go. Okay. So it's just a matter of not declaring, using that variable s, declaring it twice. Okay, cool. So I think there's a lesson here. And the lesson is, one of my strategies to try to avoid going insane when I'm programming is to try to get little bits of my program to work first. So that's what I did. I mean, it seemed really simple. Hey, let's declare a couple variables and then just try to send them over sockets. Well, I had all kinds of little errors that needed to be tracked down. But what's cool is now that I figured it out for server, it should be relatively straightforward to figure this out for client as well. So what I'm going to do is a little Emacs magic. So I'm going to highlight all this stuff. Maybe to here. And I'm going to wipe it, Control Y, and then yank it back. Then I'm going to say, all right, I want to edit client.cpp. And now we'll go into the client code, and inside that do loop, I'm going to dump all of this stuff. Actually, I think I'll back it up. And after this cout, I'm going to yank this stuff. All right. And I'm going to get rid of the do loop. So we'll have the client say, hey, I'm the client, and I'm waiting for a server message. All right. We're going to be getting all of these objects transmitted to us from the server. So I don't want I to be 42. I'm going to set I to 0. I'm going to set D to 0. I'm going to set the string to an empty string. And we'll declare the student Ben, but we're not going to set anything about Ben up. We're going to get that from the server. All right. So the server is the client is a reflection of the server. So where the server is sending stuff, the client is going to receive stuff. So we're going to put in the receive command. And we're saying at this memory location I, for a size of int, stuff whatever the first set of bytes you get from the server. All right. And of course, the first thing the server is sending is the integer I. All right. And then we're going to do the same thing for the double. And we are going to we'll have some shenanigans that we have to do here. So let's look at that. So when we receive the buffer from the client, from the server, I'm sorry, so we'll receive the integer, we'll receive the double, then we're going to receive the serialized string, the serialized C++ string. They'll say like hello from server. So that's going to end up in buffer here, but then we need to convert it into a string, and that's pretty straightforward. We can just say str equals buffer. That's all we have to do. And C++ will say, oh, buffer is a C string. Great, let's convert that into a C++ string. That's all we have to do. All right, why don't we output the data that we received? Okay, so we'll do that next. And then after that, we're going to, what we'll do is we'll say buffer equals thanks. That's the message from the client, and then we'll send that back from the client to the server, and then we'll end our program. If you recall, the server is, let's go take a look at the server for a second. So the server, after sending the data, ID and the string, the server is going to block waiting for the client to send it a message. So the message we're going to send is thanks. That's what we're going to send. Okay? All right. So after we've received the integer, the double, and the serialized version of the C++ string, let's output the results. All right. So we'll have the client I has the value of I, and then we'll print out D has the value of D, and we're going to print out str has the value of str. All right. So again, I haven't done Ben yet, the more complicated object, but I just like to get something running so I can feel good about the program. Okay. So assuming I did everything right, this should run. The server will send this data to the client, the ID and the string, and then we'll just dump it out and we'll be able to see it. All right, so the way to, in order to make this work, I think what I'm going to do is do a new tab, and we'll have some cool, I like ocean, that's a cool color. All right, we'll just make that a little bigger so it's a little more legible. And I'll get over to the virtual machine, and we'll get into that client directory. Let's spell it right, lectures, and we're doing sock stream. Okay, and we'll go back here, and we're going to save this and make. Oh, okay, we gotta fix that because you have to declare looks like we need string and string.h, and we need student. All right, awesome. I should take care, oops. Now why did that, oh. Oh, okay. So we need to get that thanks into the buffer. So I think we can use string cpy, and it's to from. Okay, awesome. All right, so let's run the server. And over here, we'll run the client. Let's take a look at what we got from output. So the server says server and client establish communication, waiting for server message. Client received the following data: 42, 42.2. Oh, cool. So the integer and double made it there, and it looks like our string hello from server made it as well. All right, there's a bogus message here that says type in your message, press enter, because we're not really doing that anymore because we're just trying to send data. And then over here, the server sends the data, waits for the client message, the client sends thanks, and we're all done. All right, so let's Emacs that client.cpp. down at the bottom, we will get rid of that cout. Okay, cool. So I hope this makes sense to you so far. Sending a buffer and sending the 4 bytes of an integer or double, those aren't really any different from each other. And receiving them, receiving an integer and a double or a buffer, that's all pretty similar. The only weirdness here was our buddy, the C++ string. And it was weird because C++ string is not flat. There's all kinds of nooks and crannies and different bits of data that you have to sort of search out. And we actually don't really know how it's constructed anyway. So we have to figure out a way to flatten it. So the way you flatten it is through a technique called serialization. So you go after the data that makes the most sense and you send that data. So in the case of this C++ string, there is a method called C_str that will return the bytes that make up the actual string. So we took that information, copied it into our generic buffer, and we just sent that buffer. And we did it in an intelligent, well, in a simple way, which is that we always send the buffer of the same size no matter what. So we're always sending 1024 bytes. We could be smarter, but it's more complicated to do that. All right, so I hope that all makes sense to you. And now what I want to do is look at how would we send an object like Ben. So Ben's really complicated because Ben has a couple of C strings, a whole bunch of them, plus an integer. So, but yet we want to take all of that information, send it to the client, and have our Ben student object reborn in the client. So how do we do that? So one way would be to just do a series of send commands right here in the main program. But a better way to use procedural abstraction would be to create a special method called send that is in Ben that knows how to send a student object. So let's take a look at how we would do that. So student.cpp. So we're going to create a new method called send. We'll do that right down here. Okay, so I guess it's void. And the goal of this method is to just make a whole bunch of send calls to send the contents of the student object to the caller. So we know the contents are going to be last, first, address street, address city, address state, and also the zip. Okay. So there is a technique here that we have to figure out, which is basically converting a string, a C++ string, to a C string and a buffer. And it's kind of annoying because basically we're gonna have to do it over and over and over again. So it might make sense to make a method to do this, but I don't know, we'll see. I want to grab the code from our send thing because it has a lot of the smarts and how we do this already done for us. So let's take a look at that server that does a send. So I'm just going to grab this code. If you're wondering how I'm doing this, I'm hitting Control Space, then the down arrow, and then Control W, and then Control Y to bring it back. And then I'm hitting Escape X, buffer, menu, and that gets me to all the files I'm editing at the moment. And then if I do Control Y, that's stuff that I copied, that I marked, I can use. All right, so the way we're gonna do this, I think the order should probably be the same order as right here in this result string. We're gonna do last, first, street, city, state, and then zip. A lot of strings. All right. I guess I can say that's the zip. So maybe I'll do that at the end. I said we're going to do it in order, but I don't want to lose that. not sending any doubles, but then I do have this pattern, okay? So the pattern is we're going to send last and then we're going to do this send not CS, that's not the name of our socket. Socket name is socket, and here's socket. Okay. All right. So we're just going to repeat this pattern over and over again. I guess it's okay. I'm going to have to create a buffer though. So let's create that. Care buffer, and we'll call it buffer length. And we'll say static int buffer length equals 1024. Okay, so that's our buffer. Yeah, I don't know. It's probably hard to say which is more work. I'm just saving an extra line of code, so let's just do this for all of our members here. Yeah, okay, cool. So we have the last name gets transmitted, then the first name, then we have the address, and we just have to repeat that here as well. And then the city. It's a little bit repetitive here, but that's the nature of serialization. Okay, and then we have the state and zip. So we just have to do the state as our last string. And zip. Okay, so let's see if we've managed to serialize this whole thing. So we've got the last name of the student, the first name of the student, the address of the student street, city, and state, and then zip. All right. Now that we have a send method, let's take a look at our server. That's going to send Ben. All right. Super cool. Now, of course, on the client side, we have not a Ben send, but a Ben receive. And that's actually going to go up here. And we're finally going to say cout client Ben dot toString. So we'll call the toString method, which will serialize Ben. Actually, it's sort of serialized. It'll send Ben to cout. Not to cout, sorry. It'll create a string, and then we'll have that lovely string that we'll be able to use in our cout command. Okay, so the thing that we have to write then is the receive code for Ben. That is the mirror of the send code that we just wrote. All right, so let's take a look. Well, let's take a look at how we did. When we received the string, we copy, got it into our buffer, and then we set something equal to buffer. Okay, perfect. So let's take a look at our student. All right, so we have this lovely send method, so we have to create a twin of that, which is the receive method. So I'm gonna just copy all of this. And now say, okay, I've got a copy of the send method, so we'll call this receive. And let's take a look at what we're gonna do first. So the first thing we're gonna do when we do this receive is we're not gonna do a send anymore, we're gonna do a receive. Whoops, let's get up there. All right, so we're gonna say receive from the socket into the buffer length. So we're gonna receive basically 1024 bytes. And we have to take that and convert it from a C string into a C++ string. And so the way we're gonna do that is we're just gonna say last equals buffer. And that's pretty much it. So the receive seems to be a lot easier, right? All right, so if we have that, I probably might make sense to just copy and paste this. All right, so first, then we're going to receive address dot street. Then we're going to receive address dot state city. Oops, I think I forgot. I may have forgotten one, but we'll fix that. Okay. And then we're going to have address dot state. And then we're going to have one last one, which is our, no, that's good. Address dot state. Yeah, street, city, state, and then we're going to pull in the zip code. So the zip code, we're just going to say receive in from the socket into zip size event. So that should pull in the zip code. All right, so a little bit more straightforward than send because we don't have to mess around with memcopy. And that's because the C++ string knows how to take a C string, which it's treating buffer as if it were a C string, and convert it directly into a C++ string via the assignment statement. So we've got last, first, street, city, state, and then our zip. Okay, so that's what receive is going to do. Super cool. All right, so let's take a look up at the top here. Yeah, all right, I think we're good. Now, we have to get into student.h. Whoops. And we just have to add our method, our two methods. We've got a send method, and that is of type void. And we have a receive method as well. And we'll just make it look nice and line up here. Okay. Let's take a look at the makefile. We don't have anything for student, so we'll add that. Student.o is created from student student.cpp and student.h. And client has a dependency on student.h as well. And server also has a dependency on student.h. And server needs student.o. And client also needs student.o. And I think we're good there. All right, let's see if we had any errors. Oh yeah. Oh, we have to include here in student.cpp the stuff that you need to make sockets work and memcopy work as well. So let's do man memcpy. What does it require? It needs string.h. Okay, so I'll make sure we include that. Okay, string.h. And might as well include, it looks like it's already got the string stuff, so we're good there. So we need to include these two as well. Now I could have Googled this, but man pages are just amazing. All right, and we'll add those two. All right, so looks like we still have a few errors here. So let's see if we can figure them out. It's not really happy about things like those members, last and first and all that stuff. So let's figure out why. Oh, because I didn't put student in front of here to make it a member of students. I think that's why I wasn't happy. I feel like we're getting closer. Let's see if we can find the first error. Usually if you get rid of the first error, it will help you get rid of other errors as well. Whew. All right. Ah, okay. This is a little trickier. I'm having like a flashback because I know I've written this code before and I've gotten into this problem. Now we have two send methods. And so we want to make sure that we're not trying to call the student send method. I'll show you what I mean. So there's a student send method, but then there's also this send method. So like which send method are we calling, right? So I think I'm just gonna, it's kind of cheesy, but I'm just as an experiment, I'm gonna change that to sand, and I'm gonna change this to receive, okay? Just to see if that gets rid of the errors. Okay. Yeah, it did. Um, so the challenge though is, I want to, oh no, I guess I'm not sure I did fix it. So all right, let's take care of this in server.cpp. I might just spell it out or something. Okay, let's do that. Okay, much closer. So let's look at student again. And I think I just screwed up here. Instead of saying zip, ampersand zip, it should be address dot zip. And let's just check up at the top. I probably messed up the send function as well. Okay, cool. So I think we're in good shape now. All right, now, ideally, we should probably correct those names. Like instead of saying sand, maybe I would say, I don't know, sender. And instead of receive, I could call it receiver, or RECV, I could call it receiver to make it consistent. And then I think things would be cleaner instead of misspelling send and receive. But the idea was that the method names were the same as the C socket calls that I was making, and the compiler was getting confused as to which one I was talking about when I made a call. All right, so let's try this now. All right, if I run server and over here, and I run client over here, look at this. I got Ben Dugan transmitted from the server to the client, and the client says thanks at the end. All right, so now let's just look one more time at the awesomeness of this thing. So server.cpp says, I just want to send this student object by saying ben.sand. And the client object does the receiving. So we'll just change this. So it's bugging me. It's got to be right. Receiver. Okay. And we'll change that from send to sender. And we'll change our receive to receiver. And I think we're done with this. Gotta fix client.cpp as well. All right, so I'll make sure that this is available for you so that you can download it and check it out. And I think we're good with the discussion about serialization. That's really what this was about. How do we take data of varying types and send it across interprocess communication using message passing? And in this specific case, how do we do it using sockets? And the cool thing about the techniques that I just showed you here, from a real simple object like, or real simple data like an integer, to a much more complex and rich object like a student, is that you now have the ability to send any kind of data from one machine to the next. Now, actually, there is one little tricky part that you have to watch out for, and that's this. When you're sending data that has byte ordering, that's important. So this can happen when you send data from one type of machine to another. So like, let's say we're sending data from, well, this used to happen with sending data from like an IBM PC to an Apple PC. Those two types of computers ordered the bytes associated with things like integers differently. So one put the largest byte first and the smallest byte last in a 4-byte integer, and the other put the largest byte last and the smallest byte first in a 4-byte integer. So if you were to transmit something with a send from an IBM personal computer to an Apple personal computer, you would get the bytes in the wrong order. So there had to be some intelligence in how that gets done. Nowadays, most computer architectures are all the same, so the byte ordering is the same. But there are some machines where it's not. So that's like a little tricky thing you have to watch out for. Okay, so I think what I'm going to do is stop right now, and then we'll pick this up as we explore one last socket-based interprocess communication technique, which is something that's called remote procedure calls. They're really, really cool. So I look forward to showing that and sharing that with you.